Alright guys, welcome. Let's jump right into it. This last couple weeks has been the finish line of a project several years in the making, and I struggled. So as you hear right here, maybe the compressor was laboring. Now it's running fine. Check valve is bad. Oh, I chased leaks. I chased my own dumb mistakes. Just sometimes you have to be persistent, and this one really it required some persistence. So follow along, take you through the process, where we started, where we ended up. We got some leaky boys. So a little backstory, I picked this compressor up in 2015. Here I am unloading it out of my old Ram pickup. It basically sat until 2023 when I started acquiring parts. And then I got serious in 2024, hydro tested the tank because it was very old, it was riveted, and it failed. So it was a good thing I tested it. Went on the hunt for a new tank, found a 60-gallon upright, and I thought if it has any rust, it'll be on the bottom, now on the side in the new horizontal configuration. Did some modifications to it, hydro tested that to 1.5 times MAOP, looks good, and transferred the brackets from the old compressor over, painted everything up, got to this point, and then got distracted. So let's finish something. Let's finish a project. So we're going to kick things off by pulling the unit out from under the pallet racking. It's going to live in this spot, just turned around to put the pulleys and the belts, up against the wall in a slightly safer configuration. It came with a really terrible fan shroud. This came out of an industrial setting, a bakery, I believe. I'm not entirely sure why it was taken out of operation. Nothing had failed, but like I said, the hydro test, the tank didn't make it, so it was going to fail soon. That was 10 years of sitting later, but 10 years of sitting out of use, so who's to say for sure. But here we are, tightening up the belts that actually came with it, very old belts, and I didn't want to get too into the weeds until I at least saw the thing turn over and make a little bit of air. It came with kind of a hodgepodge of piping, and somebody had added a second check valve. In hindsight, that should have been a bigger red flag, but I assumed that it was functional. Yeah, joke's on me for assuming. So, you see the hydraulic hose I have off the side is to dampen the connection to the rigid piping. Oh, nice catch. And just getting it nestled back into its final spot here. Having a pallet jack in the shop is indispensable for stuff like this. So I'm adding a backer board here, just something to be able to, the sheeting on the wall is just like a poly sheeting. It doesn't have a lot of structural strength, so this is some polycore steel panels, just makes a nice backer. So seeing as how this is a true 5-horse motor, I am running a square D mag switch, or a magnetic starter. So that takes the load off the pressure switch, acts as a big relay, and then a thermal fuse. So we're getting the pressure switch wired up here. Yep, looking good. I did want to take a look at the oil and just see if it had any glitter provided. It came out looking so nice. I was tempted to pour it right back in, but I didn't. I put in new compressor oil. I deserve a pat on the back for that. Anybody that knows me knows that was hard. So the breaker's installed, and I'm running gauge copper over. I'll clean the wiring up later, maybe. Nah. Split bolts on the wire connectors. I did make sure to write down, which pair of wires were hooked up. I'm trying to plan this system for kind of expandability and making sure that it's a cost-effective system. So I did a mix of things here. I have the galvanized piping going up into like the attic area, and then I bought a large spool of 1/2-inch DOT semi-truck airline. In bulk, I got a really good price on it per foot. The push-to-connect fittings are pretty inexpensive. It makes it easy to cut it and tee into it if I want to add something. So it's kind of a hodgepodge, but in my head it made sense. So that's what the manifold sitting on the table. And then what I'm assembling here is the regulator, drain valve, pre-regulator gauge, and ball valve, and then union going to the hydraulic hose. Now I did make an error here where I put the gauge after the ball valve, meaning when the ball valve is closed, I can't see how much pressure is in the tank. I went back and flipped that around to correct that because I want to be able to see what's in the tank regardless of whether the valve is open or closed. So later shots you'll see that correctly, but for now I have it. Yeah, that was another silly mistake among many. Yeah, you can see the ring jiggling on the interstage pop-up valve, the little valve right above the pressure switch. And it's not happy. It's running really slowly and laboring really hard to run. So this was a little discouraging. I did throw the belts, but again, those belts were old, they were junk. And here's a bit of what I learned. So what I later learned is this is a check valve that was in the high stage head. It was installed backwards, and I think that's the reason that they had the swing check also installed. So yeah, here's the diagram of what the check valve should look like, and it's a nylon seat, spring-loaded check valve. I'm sorry, reinforced Teflon, not nylon. That sounds better, right? It's moving air, it's not laboring. So that test was with a new check valve, not the right one, but just one I happen to have in my box of plumbing fittings. It cycled, it made air. Aside from the check valve being horrible, it actually produced a lot of air. Math says about 20.5 CFM. So after a little research and through the magic of Amazon, I ordered a new compressor check valve, an intake version. It came the next day. It was pretty inexpensive, so trying to repipe this and get rid of all of the weird piping that it had. It had, reducers and bushings and up sizes and down sizes. So trying to get everything to 3/4 pipe from the high stage compressor all the way to the tank. No silliness, no extra fittings or extra leak points. So a mix of a few new fittings and replacing or repurposing some of the old fittings. I was able to get a layout that is pretty good without having to cut and thread anything. So this is my silly mistake, another one. When I put the check valve into the tank, the unloader is before the check valve. So as soon as it unloads, the pressure switch turns the compressor back on because it thinks that it's low on pressure, and it just sits there and oscillates, and that's no good. So easy solution, I noodled this for a while, was to move the unloader to the end of the tank. And while I'm doing this, I'm rewiring both the pressure switch, and then I added another switch leg so that I can have a switch, in a convenient spot. Now that I've gotten everything kind of resituated, I'm going to try and finish up the nylon lines over to all of the access points in the shop. And this is an amazing improvement from where I started, because basically I had a small pancake compressor and one hose that I would drag around as I needed it. And now I think I'm going to have something like 7 or 8 access points. So this is going to be a huge improvement. Regulator's fixed. All right, so how about a quick recap? Rolling through the clean room. So we've got 2 air lines on the main workbench. These are actually a hex bar that I turned into an NPT to PEX fitting, and then cut the plates out, and they're mounted into a work box. So this was several years in the making. So yeah, got 2 of those to service the whole workbench, and then those route over and into the mechanical room. So we'll come over here for just a minute. So we've got a main line coming out here that feeds the junction block on the Bridgeport, that feeds air gun, and the power draw bar. And yeah, that's it for right now. I might add another fitting to add an airline connection. So we'll come up here. We've got manifold here, 2 lines. One is going to stay with a pistol whip to service the Langmuir. And then I may add another junction block off of that as well, but that's the feed coming through the wall. I 3D printed these electrical box sized like escutcheons or grommets almost. Those are 2 pieces that tighten down and pinch the drywall, and they support the 1/2-inch pipe coming through the wall. So we step on the other side. That's where that pipe comes through, comes up, passing through another 2-port manifold. That's going up, feeding a FlexZilla hose. And then that is going over to the main branch. So we've got this run, the run that we just saw coming out of the mechanical room. And then there's another right there on the post, so that'll service the 2 lift bays. So these are 1/2-inch DOT rated nylon tubing that's going up to the manifold you saw me build earlier, main line down, and that's what's feeding into the post-regulated line, along with the last one is a quick manifold I threw up here to service kind of the pallet racking workbench as well as the general work area here. So everything appears to be working. The only leaking that I'm seeing is from the power drawbar on the Bridgeport. Pretty normal. Those things just seem to eat air. So for now, I'm gonna leave it turned off, and I'll go ahead and kick the compressor off. All right, let's try the outro again with a little more enthusiasm. It is late and I'm running on fumes, but it's been a great week. I'm really excited to have knocked this project out. It's been on near the top of the list for a long time now, but I've been scraping by with a little compressor and a hose, and I need big air. So it's done. Dan, I finished the project, and for my coworkers that think I'm a robot, I do make mistakes sometimes. So if you made it this far, again, thanks for watching. Consider subscribing if you haven't. I like watching that number grow. It's kind of fun, so keeps it. I'm gonna get teary-eyed if I keep going. That's enough. Back to car stuff next week. Thanks for watching. I'll see you guys later.